Every moment of your life flows in one direction. You wake up, live your day and go to sleep, never the other way around. Yesterday is a memory, tomorrow a promise. You can't unscramble an egg or unspill milk. The movie of your life only plays forward. This relentless, one-way journey is the most fundamental experience we have. It's a current that carries everything from microbes to galaxies downstream into the future. We are all passengers on this cosmic river, time. We feel its passage in our bones, in the turning of the seasons, in the lines on our faces. We measure it with clocks and calendars, but what this force? Why does it have a direction at all? In space, we can move any way we like. In time, we're locked into a single forward march. This isn't just a casual observation, it's one of the deepest mysteries in science. The forward flow has a name, the arrow of time. Like an arrow shot from a bow, it flies in one direction, never turning back. It distinguishes the past from the future, governing every cause and effect. A glass shatters, but we never see the shards leap back together. Yet when we look at the fundamental laws of physics, we find something shocking. For the most part, these laws don't care about the arrow of time. So if the underlying machinery of the cosmos has no preference, why does the world we experience so clearly have one?
Exactly, and that's where the real story of time's arrow begins.
The universe plays by probability, not just possibility.
To understand, we must look not at the rules themselves but at the way the game is played. The answer isn't in the laws but in the odds.
So what makes the impossible so certain?
The stargazer smiles. You're touching on a cosmic paradox. We feel time as a one-way street, but the equations of physics point both ways. It's as if the universe is written in a language that can be read forwards and backwards, but we only read it one way.
So the rules don't forbid time from going backward. Could a broken cup reassemble itself?
The laws wouldn't be broken, but the event is so astronomically improbable, it would never happen in the lifetime of our universe. The universe doesn't forbid it, but it stacks the deck so completely against it that impossible is the only word we can use.
Imagine a conversation under the stars. A curious student, Lyra, and her wise guide, the stargazer. Stargazer, why does time feel so absolute? Why can I remember yesterday's breakfast but not tomorrow's lunch?
Most bedrock laws of physics are time reversal invariant. Imagine two billiard balls colliding, play the film forward or backward, both look plausible. Gravity works the same way. An apple falls from a tree, run the film backward and it leaps up. Newton's law doesn't care. Maxwell's equations for electromagnetism, no built-in preference for past or future. Even quantum mechanics, with the Schrödinger equation, is largely time-symmetric. The universe at its core is ambidextrous with time. So where does the arrow come from? If the microscopic world is a two-way street, why is our world a one-way highway? The answer isn't a law of motion, but a law of large numbers, a law of statistics and probability. It bridges the gap between the reversible world of particles and the irreversible world of people and planets. This concept is one of science's most profound ideas. It's called entropy. Entropy is the ghost in the cosmic machine, and it's the key to understanding time's arrow.
Yes, entropy is the engine of time's arrow. It's the universe's way of playing the odds.
So entropy is the reason time moves forward?
Not a force, Lyra. Think of it as a measure of order and disorder, the number of ways you can arrange a system without changing its appearance. A sandcastle. Only one way to arrange the grains for a perfect castle. Low entropy. A messy pile? Billions of ways. High entropy. The universe prefers to move from states with few arrangements to states with many. This is described by the second law of thermodynamics. In an isolated system, entropy can only increase or stay the same. This is why you can't unscramble an egg. An intact egg is low entropy, a scrambled egg, high entropy. There are vastly more ways for the egg's molecules to be scrambled than perfectly arranged. The second law is the one physical principle with a built-in arrow of time. The past is lower entropy, the future higher. Time flows in the direction of increasing disorder. It's not that the universe go back to order, it's just overwhelmingly unlikely. The river of time flows downhill, from order to chaos.
So what is entropy? Is it a hidden force?
Think of a drop of ink in water. At first it's a concentrated drop, low entropy. Soon it spreads out, high entropy. You'll never see the ink spontaneously gather back. The universe is just playing the odds. When you burn a log, You turn ordered energy into disordered heat and light. You can't reassemble the log. The total energy stays constant, but its usefulness degrades as entropy increases. The forward march of time is linked to this cosmic trend. We experience time moving forward because the universe moves from order to disorder.
Sometimes the deepest truths are hidden in the mundane. The universe is that scrambled egg, every star, every galaxy, every thought, part of a cosmic process of increasing disorder.
So the arrow of time is really just the arrow of entropy. Things just get messier?
The Big Bang. Nearly 13.8 billion years ago, the universe was compressed into a state of unimaginable density and temperature. You might think this was chaotic, but in terms of gravity, it was exquisitely ordered, low entropy. Matter and energy were smoothly distributed, a cosmic equivalent of all the air in a room rushing into one corner. This initial low entropy state set the arrow of time in flight. Since then, the universe has been unwinding, expanding, cooling, and becoming more disordered. Stars form and die, galaxies collide, black holes evaporate, all increasing entropy. The universe had to start ordered for time to flow. Why did it begin this way? That's perhaps the biggest mystery of all. Some physicists speculate it's a feature of quantum gravity. Others suggest we live in a special region of a larger multiverse. Whatever the reason, this initial order is the ultimate gift of the cosmos. It's why we have structure, complexity, and life.
You've reached the ultimate source of time's arrow, the beginning of the universe.
If the universe is always moving toward disorder, it must have started incredibly ordered. Where did that order come from?
This is the psychological arrow of time. It points the same way as the thermodynamic arrow because our brains obey the second law. We have records of the past because it was a lower entropy state. We can't have records of the future because it hasn't happened. Our sense of cause and effect, our memory, our consciousness of time's flow, all are consequences of the universe's low entropy beginning. We are creatures of the unwinding clock, temporary islands of order in a sea of chaos. Our ability to remember is a privilege granted by the Big Bang's initial conditions. We remember the past because that's where the order was. The future is still being written.
The past is a page already written. Fixed, ordered. The future is a blank page. No record yet. There's no memory of the future because those events haven't happened or increased entropy yet.
Why do we remember the past but not the future? The answer is woven into entropy. Memory is an entropy-increasing process. To form a memory, your brain creates order, but in doing so, increases disorder elsewhere.
What happens to time's arrow inside a black hole at the end of the universe? Does time stop, reverse, or lose meaning? Some particle interactions show a slight preference for a direction in time. Is this a clue or a red herring? These questions push the boundaries of our knowledge. Perhaps time is an emergent property arising from a deeper, timeless reality. The mystery of time is a landscape to be explored.
It's the best story science can tell now, but it's far from complete. We stand at the edge of a great ocean of mystery.
So is that the whole story? Is time just entropy?
We are stardust, animated by the flow of time, able to look back at the low entropy past and contemplate the high entropy future. Our science, art, and civilizations are attempts to build pockets of order in a universe moving toward disorder. Next time you watch an egg scramble or ice melt, remember, you're witnessing the arrow of time in action. You're part of this flow, a thinking, feeling part of the universe's journey. Never lose your sense of wonder. The greatest discoveries are yet to be made. The river of time will carry us toward a future we cannot remember but can help shape. The cosmos awaits.
The quest to understand time is the quest to understand everything, from the quantum to the cosmic. We are the universe's way of thinking about itself.